Dear friends, hearty welcome to the 6th day session of our special crash course focus on TIFR GS 2025. Hope that all of you have enjoyed the mock test held yesterday. I take this opportunity to appreciate Mr. Lalit for taking all the efforts to prepare such a mock test so that you will get a direct hand experience of attending the TIFR exam. So today, Lalit promised to discuss that questions and the way of solutions to that questions in today's session. So I'm sure that that will certainly help you to mold your thinking process in answering these type of questions. And also, I asked Lalit to share some tips and tricks to follow in the examination time. So today and tomorrow we will concentrate on this issue, and day after tomorrow the most awaited TIFR exam is on that day, on this Sunday. So yeah, without any delay, we can directly go to the session. So our resource person Lalit is ready. Welcome everyone to this program. Welcome, Lalit.
Yeah. Okay. So I'm going to present my screen. So today we'll be discussing the questions from previous questions from the test paper. Okay. So let me present my screen. So there are 40 questions in the test. It's not possible to discuss all the questions in the time duration of 1.5 hours. So I would be giving hints for some of the questions and would be discussing some questions in detail. Okay. So before that, and let me tell you something that uh, most of you, you know, have, the exam is on day after tomorrow, right? Yeah, it's on 8. So if you have still not solved all the questions from TFR, I strongly suggest you to solve. But for that, I would be sharing the document. I'm sorry that I forgot to share that thing. No one reminded me. Okay, I will share the document at the last. Okay, please remind me. In that document, or 2024 solutions are there, and there is also a very free electronic copy of unsolved book that would be very good for your self practice. Okay, so I would say share that at the end of this session. Okay, so let's start with uh, some problems. Yeah, so let me first start with some problem in part A. So uh, most of you solve this problem, and this is very standard. There is a standard procedure to solve find such kind of limits in Riemann integration. So most of you did this. Okay, so let me solve this one. Okay, so first, so I will be solving the selecting questions. Okay, selected questions. So let me solve this one. Okay, uh, how to solve this one. Okay, so by the way, how many of you did this correctly in the exam? If you can raise the hand, let me see you. But one advice for all of you is that, okay, first raise your hand if you could solve it correctly in the exam and know the correct reason. Okay, because after the test exam, I asked some of the students that why this is correct. Okay, though to whom I know personally, so they said, okay. They did not give me the proper reasoning. Okay, sometimes it happens that we solve questions, I mean, we know that either is true or it false. If something is in your mind that supports that it's true, then we take it. Okay, so we should know the proper reason. But I'm not saying that you should not. I mean, take true if you think something in the exam. If you think that something is true, and you should not take that. I'm not saying that. Okay, so but I have seen that most of the students their accuracy is not good. Okay, so as I have seen in the test results, so you must be accurate. Okay, if you don't know some question, then you need not to what's so called in English. I mean, tukka nahi marna hai. Okay, so don't try to do that in the TFR exam, because the questions are constructed in such a way, they make the questions in such a way that it feels that that might be true, but that sometimes not, and it costs you -2 marks, right? Because suppose for the moment, okay, suppose for the moment you know 10 questions, okay, you know 15 questions, say not 15, you know the answer of 20 questions correctly, okay, and then you try to solve 2 or 4 questions, 5 questions, okay, but you are not sure about the 5 question, and you just do true, true, true for all, and all they are false, suppose, then you cost -10 marks, right? Your total score will be 30. So the chances of being called from the institute is very less, okay? But if you have correctly solved 20 questions and correctly in 30 hours, then you will get 40 marks, and 80%, I'm sure that 80% sure that you will be called, okay? Because accuracy matters, okay? And the cutoff for TFR exam is around, I'm not sure about the cutoff, but and I cannot also give you the idea for the cutoff, because I have seen some student who have got call in 36 marks last time, 37 marks in the TFR Mumbai. So yeah, but it depends, right? Every time it depends. We cannot sure. I mean, I cannot sure that at these marks you will get the uh, call. But what do I want to say? I want to say that do not really try to solve 40 questions in any way. Sometimes you feel, right, that we have to solve 40 questions. Just solve 25 questions. If you solve that correctly, that's good, right? Okay, so let me come back. This type of things, this type of talk we will have tomorrow. Okay, so let's come back to the solution of the problem. Yeah. So what this problem says, let f R2R be a twice differentiable function at f 1 by n equal to 0 for all n then. Okay, so some of you raised the hand, but some of you below the hand now. Why? I asked that how many of you solved it correctly. Okay, so let me tell you, okay, why this. See, you have this sequence 1, 1 by 2, okay, 1 by 2, 1 by 2 dot dot dot, okay, this is going to 0. So you have given that f1, f1 by 2, all these terms are 0, right? This is equal to 0. By Rolle's theorem, you know that you will get a sequence x1, x2 dot dot dot, which will converge to 0. How? Because see, just apply the Rolle's theorem for these 2 points first, okay? Because f is differentiable function, and f vanishes at 1, and also f vanishes at 1 by 2, okay? So by Rolle's theorem, there would be a point where your derivative will vanish, okay? In the same way, you can apply in this interval and get a point between 1 by 2 and 1 by 3 such that your f dash vanishes, right? In this way, we get a sequence x1, x2 dot dot dot, which x1, x2 dot dot dot, this which converts to 0. Can you see that why it converts to 0? It's clear, right? Because xn is, between 1 by n and 1 by n plus 1. And both the sequences, by the way, yeah, both the sequences go to 0. By squeeze lemma, xn goes to 0. Okay, this is the justification. So xn goes to 0. So now we have a sequence xn such that this xn satisfies f dash xn equal to 0 for each n, right? Yes or no? So the by continuity of f dash, we have, what do we have? See, whenever we have a continuous function, say f, and it is continuous at in particular take x equal to 0, right? Then any sequence which converts to 0, we have fxn converts to f0, right? For a continuous function. In place of f, we have f dash here. F dash is a continuous function because your f is twice differentiable, right? So that's why f dash will be continuous. The bicontinuity of f dash, we get that f dash 0 equal to 0 because this f dash xn is a 0 sequence. It will convert to 0. But at the same time, continuity tells us that this f dash must converge to f dash 0. But the sequential limit of a sequence is unique. So both these are equal, right? Okay. So in this way, we get f dash 0 is 0. Piyush, please admit the students if you can. Okay, so did you get this? Right? Now what do you have? You might think that we would do the same thing. We will apply the Rayleigh theorem, okay, and for the f dash, and we will show that f dash double dash 0 is equal to 0. But the problem is there. It is not given that you are twice different. I mean, this second derivative is continuous. It is not given continuously twice differentiable. It is given just twice differentiable. Okay, so this thing cannot be applied further. Okay, f double dash 0. In fact, it is 0, but we cannot conclude from this method, right? Do you understand? What do I mean to say? Yeah, so what do we do? Okay, let's try to conclude. Let's try to, determine, evaluate directly by the definition. Okay, so this is equal to x. Okay, let me know what is the definition. You tell. X tends to 0. What should be there? You should speak, right? Make it interactive.
Sir,
Huh.
we have using the definition, the first principle.
Yeah, first principle. So what
So
should I
f
write?
dash x minus f dash 0
Okay,
over x
f
minus 0.
okay, f dash x by x, right? Because that is 0.
Yes, sir.
Yeah, this is 0. Okay, so what can we do now? You should think.
A limit exists.
Yeah, this
So
limit
we can
exists.
use the sequential definition of limits and move via the sequence xn.
Okay, so I can write because this limit exists, right? It is given because f double dash is, you have given that f is twice differentiable. So this limit exists. So limit can be found by approaching any sequence, right? So what sequence I will take? I mean, this thing, right? Yeah. So keep this in mind that this is well defined. Okay, whatever I have written here, this is well defined because your xn is never 0. Okay, see what is your sequence where your xn lies. This is in between these two types of real numbers, right? Yeah, here. Okay, so now we have to find the limit of this sequence. This sequence is again 0, 0, 0. The limit of a constant sequence is 0. Okay, so in this way, we get that both the derivative at 0 must be 0. Okay, so the first one is correct. By the way, how did you solve? Some of you, listen this carefully. There is a advice for you and a warning for you. So, all of you might not have solved this question in this way. Okay, you might have different things. First of all, you I think, can these be eliminated options by taking some example? Need not be 0. I don't think that you can eliminate, right?
Sir,
Huh?
yes, sir, if I take f to be sine n pi x,
What do you take?
f is equal to sine n pi
So
x,
you are
sine
giving
of
me,
n pi
okay.
x.
So you are producing some counter example.
Yes, sir. In that case, A option is violated. I hope.
Okay, let me address this then. But that I'm sure almost that that would not, but I might be wrong also. Okay, let me know. Yeah, fx equal to
Sine of n pi x.
n pi x. But oh, you did the mistake. Usually student
It
the
is not
don't.
twice differentiable.
No. Wait.
No, sir. It is not
It is
sine
not
n
twice
pi over x.
differentiable. I
Yeah.
made the same
Okay.
mistake.
Yeah. Wait.
Oh, no, sir. I'm talking about sine of n pi into x.
No, that was not me. Some student was speaking. Okay. That was not me. Okay, so listen, student, you here, and you are wearing N also, right? Right, Rahul. Okay, you will. I mean,
Yes,
we will
sir.
give you something here also. You will write. I know that you are going to give some function of x here, but you are wearing N also, right?
Uh,
Because
yes.
function of x age means x should vary, right? So this should be fixed. Okay, such type of mistake can be made. I mean, no, should not be made. Okay, you have to be careful because this is not a function of x. This then becomes the function of n and x. Okay, is it clear?
Yes, sir. I got it now.
Yeah. Okay.
Yes, sir. This is clear.
Right. Okay. So someone was also speaking. What did you want to say?
Sir, if we take x in denominator, it is not differentiable anymore.
Okay.
Sir, if we
Okay.
differentiate sine n pi by x, we get a function which is not continuous at 0, and it cannot be taken in this case.
Okay. Fine. So see.
Uh,
Yeah.
Actually, I initially thought to take x in the numerator, not in the denominator.
So was this
But
some
even then,
question?
the problem is
No, you
of
cannot counter it, right? It is proved. I have proved it that f
yes, sir.
double dash 0 is 0, f dash 0 is 0. Okay. So if you do not
Okay.
understand at some point, then ask me this proof. This is very good question, by the way. It was asked me this was the first question in my interview of PhD. This is the first question. Then the questions also there are questions, but this was the first question. And fortunately, I did this in this way. Yeah. So I have not given this in your interview because this was my first interview question. Because of this is very important question, okay, of the differentiability. I have seen this question, I mean, this kind of question, not the same question. I think, yeah, this is somewhere, but I don't remember it, okay? So, see. Yeah, so I want to ask you that how did you solve this question? What happens? Someone unmuted. Please mute yourself. The voice is. Okay. So see, I want to give you some advice. Okay. So what advice is that? Sometimes what happens in some questions, and mostly in the TFR questions, you will see that, there are 3 options, and then the 4th option in none of the remaining 3 options. Okay. So you think that, okay, this is never correct, okay, but don't think so, okay. Sometimes it is also correct, as you have seen in the yesterday's TFR mock test. Okay, because sometimes you will feel that, okay, we have taken the count, some examples, and we have seen that this cannot be true, this cannot be true. And for the first example, you don't have the counter examples, then you think that, okay, we have to choose among these. So what? Let's take it. Okay. So don't give up, I mean to say. Don't think like that. Sometimes it may also be correct. Okay. And that happens. I have seen that. So this is the advice for you. So you should solve completely. Yeah, this is done. Okay. Now let me ask you a quick question. Suppose that f is C infinity. C infinity means, I think this is infinitely differentiable function. Okay. F1 by n equal to 0. So what can you say about the derivatives? This thing. All these are 0. Yes or no? Now quickly let me know. Yes or no? Just say yes or no. What?
Sir, yes,
Yes.
sir.
Okay. So by the way, right, yes. But if all these are 0, is f is 0?
Sir,
F is
not
0.
necessarily.
Okay, good. Right. I would not ask you for the counter example. I hope that you know that. Okay, so let me move to some other question. Yeah, let me solve this one. Okay, 10. So what is the correct answer for this?
Sir, C.
Okay, there are infinitely many subsets of S of R cube such that every subset of 3 elements of S is linearly independent. Okay, so give me the infinitely many subsets. Okay, give me one infinite subset, then immediately you will find infinitely many. Give me one.
Sir,
Yes, sir, A was the correct option.
A was the correct option.
no,
There
sir.
is no infinite subset S of R cube such that every subset of 3 linear elements of S is linearly independent. Okay. Okay, so let
Yes,
me
sir.
give you, write it here. Okay. So this, I think C is correct. So T belongs to R. Okay. So now pick any 3 vectors from here. Okay. Whatever you want. For example, if we take like this. Okay. In place of T, put 2, and in place of 3, T, then put 3. Okay. Then what happens? Oh, 1, 2, 2 is square, 3, 3 square, 1, 1, 1. Okay. So first vector is this, second vector is this. Oh, and third vector is this. So have you seen such kind of matrix somewhere? Okay, let me write it x, y, z rather. Okay, say x axis square.
Sir, may I give a simpler example?
Okay, you will give me the simpler example. Okay. Is
Sir,
this is this not simple? Okay, let me complete first. Then
sorry.
yeah. Okay, see, you take any 3 vectors. Okay, take any 3 vectors. So a determinant of this matrix is going to be non-zero, right? Do you know what is the determinant of this matrix? Anyone? So what is the determinant? This is van der Waals matrix, right? You know. Okay. So this is comes out to be non-zero if your x, y, z are distinct, right? So it means that whenever you take any 3 vectors from here, then these 3 vectors are linearly independent because they are going to make an invertible matrix C. So now this is true, right? From this set, take any infinite subset that will be linearly independent, right? And the number of infinite subsets of it is uncountable. Okay, so this one is correct. Do you understand? Is it fine? Okay, so what is the simpler example?
Sir, it was for C. I just realized, not for A.
Oh, okay. For C?
Yeah, for C. A0, 0, 0, A0 and 0, 0, A. Infinitely many subsets such that each is linearly independent.
You are taking C cube?
I'm taking A from R. So then I'll get infinitely A0, 0, 0, A0 and 0, 0, A. This will be one subset for each A. So we get infinitely many subsets.
No, but you
Uncountably infinite many subsets,
okay.
which are
So-
all linearly independent.
Right, but there is some problem, I think. Like this?
A non-zero.
Okay, so this is a finite set.
No, so infinitely many subsets S. No.
Oh,
I realized
right.
it was for C.
Right. Actually, I wanted to write there exist infinitely many infinite subsets. Okay, that was my mistake, right? It is a typo here, okay? Actually, I want to write it. Yeah, because in that case, that is very easy, right? You are right in that case, because you are answering it rightly, okay? But the thing is that I wanted to write, it was in my mind that infinite subsets, okay? Because in that case, that would be very easy, right? I mean, the question would be very trivial, right? Because everyone can do that, right? It will be very simple, because if you have studied about linear algebra, you know that these are linearly independent vectors, right? So here I wanted to write there are infinitely many infinite subsets S of R cube actually. Yeah. So this is a typo. Yeah. Thanks for pointing it out. Yeah. So is it clear now? Yeah. If you could not have, I mean,
Yes, sir,
said
clear.
this, I would not have realized it really. Yeah. So okay. So I think most of you did this, right? I'm solving those questions in which you have made mistakes, you have choose the wrong answer. I have seen the analysis of the test. Okay, so yeah, this one. Which of the following pair of subgroups are isomorphic? So what is the answer? What is the answer? If you know the answer, raise your hand. Huh? Okay, very good. Okay, so Sagnik, why these are not isomorphic?
Well, actually, I thought of them as something like modules with different dimensions, whatever.
Okay, so okay, right. You thought it right, but so are you UG or you are PG student?
No, UG.
So where do you study? So are you studying module theory?
No, I just studied it for interest, nothing else.
Okay, right. So then it's okay. Right. So okay, let me ask someone also. Okay, if someone want to tell that why these are not isomorphic.
Order of both sets are different.
How order are different?
So one might be, sir, means Q, order of Q is not same as Q into Q.
What do you mean by order cardinality?
Yes, sir, cardinality actually.
But they have same cardinality. Why they do why? Why do you think that they do not have same cardinality?
So those are not in ordinary, but I'm meant to say that it is. Excuse me, sir. Let me think again and repeat. So I got it right, but I just don't
No.
remember why.
They have equal cardinality. Okay, both are countable subgroups. countably infinite subgroup, so they have equal cardinality. Okay, let me tell you why they are not isomorphic.
We can argue
You have
the subgroups, the finitely generated subgroups of Q are all cyclic, but that is not the case for Q cross Q.
Right. Okay, good. So Z cross Z is a finitely generated subgroup of Q cross Q, but but not cyclic. On the other hand, every finitely generated subgroup, you fill it. Okay, every finitely generated subgroup of Q is cyclic. Okay, that is very easy to prove. Just take a finitely generated subgroup and then so that it's a subgroup of cyclic subgroup. Okay, cyclic group. That's very easy. Okay, write it and you will, able to do it. Okay, not difficult. So this is incorrect. Why this is incorrect? I have already told you this in class. Okay, so no quotient is, quotient means I'm talking about the proper. Okay, not this quotient. I'm excluding this. So no quotient is, so let me write star. Is no star means excluding that one. Okay, no quotient is finite. Okay, let me write here except R modulo R, but R, this one, this quotient comes out to be R modulo R cross Z modulo 2Z, and this is isomorphic to Z2, right? So it has a finite quotient, but on the other hand, this does not have. So what do you think about it? How do you do this?
Can we do some kind of induction like Z and Z cross Z are not isomorphic, then Z cross Z and
would that work? Okay, but how do you do that? Okay, let me tell you something. Okay, how do you do that? So see, just let me know that. Okay, let me tell you something interesting. Because I cannot say right here that this is module and this is rank 2025, this is 2026, so they should not be isomorphic, because of most of you don't know about the modules. Okay, without knowing about the modules, you can do that. Okay, so see, how do you do that? Suppose you have some isomorphism. Okay, so can you extend this isomorphism from Q 2025 to Q 2026? What do you think? Can you extend it? Additive homomorphism, I meant to say. Okay. Suppose if you have an isomorphy, like is there a way to extend it from Q 2025 to Q 2026? Yeah. What do you think? Okay, so suppose you have a okay. For the moment, you suppose that you have a homomorphism from Z to Z. Okay. Then you want to extend this one to from Q to Q. Then what do you do? Just send this here, right? If F is a homomorphism from Z to Z, then send A by B of Q to this rational number. Then this would be extended. Okay. Is it okay? Do you understand this? Extension means you know or not? All of you know, right? Extension means extension is very easy, right? Suppose you have a superset, say B, say T here. Then extension means some function from S to S. When you restrict to T, it agrees with your original what you have taken. Okay, so you can extend it. Okay, so what do you do? See, let me remove it. from here. Let me write it here. Okay, so okay, shift your focus here. So suppose you have a like this. Okay, P1 Q1 P2 Q2 dot 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 this. Okay, you will send this to this will go to right. Yeah, okay, wait. So phi of P1 PR dot 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 over but that doesn't make sense, right? Okay, actually, what do I mean to say? Yeah, break it. You can break it, right? Like this. P1 Q1 0 0 0 P2 Q2 0 0 0 like that. Then this one right? This would be some element of that, right? Okay, so let me tell you for the moment some other way, but this can be extended, okay? I mean, you can extend this to this, then you say that this is a vector space homomorphism because any additive homomorphism is from Q 2025 to Q 2026 is a linear isomorphism, okay? So from the Q vector spaces, this question you have seen in your 2024 exam, right? So then because the dimensions are different, then this would not be, I mean, this is a contradiction. Okay. Other way is that just take the quotient by this. Okay. Like this. Some take some, prime ideal. Some take maximal ideal, then take the quotient. If you take the quotient by this, I mean to say ki mz plus mz plus mz dot dot dot. Right here, your z plus 2025 times. Then this should be isomorphic to z plus z plus z mz plus mz plus dot dot dot. Okay, then this would be a field C Zm because mz is some maximal ideal. Okay, Zm is a field. Say for the just take it z2 2z. Okay, just take 2z. Then you will get that this one is z2 cross z2 cross z2. I mean direct sum cross z2. But how many times? 25 times. On the other hand, you will get there z2 cross z2 26 copies, but they cannot be isomorphic. Okay, because this is a vector space over z2 and this is a vector space over z2. This I mean their different dimensions are different, so they cannot be isomorphic. Okay, in this way you see that this is not, these two are not isomorphic, and this is also works. Okay, in some way you can extend it. I will write the exact formula that how can you extend it explicitly at the end of the session in the notes. Okay, so this cannot happen. And how these two are isomorphic, let me show you. Suppose that you have some polynomial, say ai xi. Just send it to first number your polynomials, number your primes like this. P1, P2 dot dot dot. P1 is 2, P2 is 3. I mean, just if you have primes 2, 3, 5, just say P1 is 2 and P2 is 3 and P3 is 5 dot dot dot. Okay. So in this way, where do you send? And then if you have this polynomial for to understand this for the simplicity, let me show you that how suppose you have this polynomial, okay, x square minus x minus plus 2. Then take the coefficient, okay, in this way, that the coefficient of x square is 1 and the coefficient of x is minus 1 and the coefficient is this one, constant term is 2. Send it to the p1 1, p2 minus 1, p3 like this. What is p1? Our p1 is 2, right? Our p2 is 3 to the power minus 1 and the p3 is 2, right? This is a positive rational number, right? So in this way you get a mapping from zx to q positive. Okay, so and it's your work to check that this is a additive homomorphism, okay? And you will see that, see, this is obviously onto, right? This is obviously onto what the map I have defined. This is obviously onto, right? Because if you have any positive rational number, then it will have a form p1 by q1. Just factorize it by fundamental theorem of arithmetic. Then you get something like this: p1 to power alpha, p to the power alpha 2 dot 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 some prime last p to the power alpha n, right? Then you will have some pre-image, something like this: alpha 1 xn minus 1 dot dot dot, right? Okay, and this is 1 1 because see, if you have two different polynomials, then they will disagree somewhere, right? I mean, some place they will disagree at some place. Then you will get the different positive rational number here, right? By the fundamental theorem of arithmetic. I mean, this you can check. Okay, I'm just letting you know. I'm not filling here the details. You can check it. Okay. Is it okay? Okay. So now this question most of you did. Okay. So I'm not going to discuss this. This was very important. How did you solve this, by the way? How many of you did? How many of you solved it? Can you raise the hand? No one could solve it, but I have seen that a lot of students did it correctly. So तुक्का मार रहे थे क्या फिर?
Sir, which one?
This one, 18.
सर मैं z और zx में कंफ्यूज हो गया ऑप्शंस में. It said I intersection z, तो मुझे लगा 0 ही दोनों में है. क्योंकि z में तो सिर्फ नंबर्स ही रहेंगे, तो 0 के अलावा.
जैसे ना देखो, इसका मतलब क्या है?
Z उधर zx है ना, वो मैं just read it as z.
इसको
नीचे वाले को ऑप्शन ए.
नहीं, तो ये zx नहीं है, z ही है.
z ही है.
हाँ, i का इंटरसेक्शन z के साथ तो नहीं, तो i आ जाएगा ना. बहुत ट्रिवियल नहीं हो जाएगा फिर? जैसे कोई रिंग हो, उसकी आपके पास सब रिंग हो, इफ यू इंटरसेक्ट इट विद, देन यू गेट i, right? It is z.
Yes, sir.
Okay, so
Yes, sir. Yes, sir.
who wants to tell it? Okay, this is very, very good question. Okay, try it. I want you to answer this one.
Sir, f and gx are two irreducible polynomials of zx. So it means fx is a polynomial with integral coefficients, and gx also is a polynomial with integral coefficients. And I is a means a polynomial string generated by fx and gx.
So what is your answer first? Tell me the answer.
Sir, B.
Okay, why?
Sir, it's not necessarily true. We can generate all polynomials with the help of only two polynomials. Because sir, zx is not
okay, right. Just go to
has
the
infinite dimension. Hence, two vectors cannot be used to create all vectors, and zx cannot be created using two functions only. So
Sir.
I cannot be equal to zx,
Hmm.
and I was third option is almost eliminated, but we can generate some functions. At least fx and gx are two functions which cannot be generated using fx and gx. And I intersection z is not equal to 0.
I
Because
did not
fx
understand
and
that.
gx,
Okay, so
fx
someone's.
and
Sir, can I
Yeah.
tell?
Yeah, okay. Yeah, Sohan.
Sir, since fx and gx are irreducible polynomials of zx, and
Right.
I is nothing but the GCD of fx and gx.
Okay, but the GCD is 1.
Yes, that is why intersection is non-zero.
Yeah, okay. But intersection is non-zero mean then what does it mean? You mean to say that 1 is in I. Does that not mean that this happens? According to you. Okay,
Oh, yes, sir.
Yeah, I want you to answer it. Okay, this is very good question, really. Because see, and you should not say that this is correct. Okay, because if this is correct, then this must be correct. Right? So in the exam, you can just say that it is not correct. But we are not in the exam now.
It was not mentioned that f and g are different.
Okay, so let me not solve this question. Okay, let me give you some hints and you will solve this question. And I would be happy if you will solve just by, grasping these hints. Okay, the hint is that fx and gx is obviously irreducible polynomial and their GCD is 1. What Sohan, said. Yeah, this is a hint for you. Now, see, what you have to do, you say that this is correct, right? You know that this cannot be correct. And what you can do that why I have put this option here, right? Because you will take some example of irreducible polynomials like x and x plus 1. Then you will see that, yeah, this is going to be true in this case and this is going to be wrong. And if there is some fourth option that can also be eliminated. That's why I have put this one. Yeah, indeed, this is correct. But let me know why this is correct. What you have to show that the I will contain some integer, right? So how do you show that? The hint is that GCD is 1. Okay, try to solve it. Let me give you 2 minutes. Okay, everyone. If you have solved this, just raise your hand. Don't let it know to others. Okay, let them give chance also. Then I will tell you that how do you think such problems in exam. Okay, suppose if this problem is in exam, then how do you solve it? Okay, I will tell you the way. Just take 2 minutes. Okay, your time it starts now. Take 2 minutes and solve it. Try, please don't give up. Okay, you can do it. I know. Really, you can do it. Okay, okay, someone did it. Okay, very good. Okay, Sangavi, how did you do that?
There exists an reducible h of x in z of x, which cannot generated by I. So
There,
I not equal to z-topics.
no, you have to prove that I contains some integer. I can be, I mean, you have to prove that I contains some integer, right? Obviously, I cannot be equal to zx in case if you have some irreducible polynomials, but you have to prove that I contain some integer. Okay, Sagnik, you did it, right? Okay, so let me know.
Okay, sir, we can think of f of x and g of x as polynomials in qx.
Okay, yeah, right. So your idea is correct. Yeah, okay. I understand. You
And
have done
in qx, Bézout's identity holds.
right. Okay, so let
Now,
me
so
write
we
it.
will,
Yeah, okay. I understand you did it. That was enough to say that fx and gx are in Q. Yeah. So see, Sagnik did it. Fx, gx are in Qx. So because this is a PID, right? And the GCD of fx and gx. And see, if they are irreducible in zx, so they are irreducible in Qx. Okay. You should understand this first. So there exist polynomials Q and T such that this happens, right? Right, because this QX is a PID and you can write the GCD as a linear combination because this is a very important property of PID, right? What I told you in the some last class, I think last class maybe, but I have told you it. So now multiply by D, right? Which clears out all the denominators of the polynomials if there are. Okay, so this comes out to be right here D of, sorry, D, right? We can multiply by some D, right? Because to clear out all the denominators, some integer, which clear out all the denominators of these polynomials. I mean, the polynomial QX and the polynomial TX. This can happen, right? If suppose you have a polynomial like this, then you can choose an integer which clears out all the denominators. In this case, it is 6, right? So now what happens that you have got like this, okay? Tx, gx, ttx equal to 1, right?
equal to D.
Yeah, thanks, D. Okay, so this D is in your ideal I because it is by definition, right? Because this is in now zx because we have cleared all the denominators and this polynomial is also in zx. So this D belongs to I because D is in the ideal generated by fx and gx. So I always contains an integer. This is correct. Okay, all others are incorrect. Is it okay? Right. So I expected that all of you will do this question, but not all did. Why? This should be done, right? Because I have told everything. I had told everything about this group. Yes or no? So is there any question in this still? Because this is very important group. And you should solve some questions, okay? Let me tell you and let me revise it here. Let me recall that Q modulo Z isomorphic to Q modulo NZ for N belongs to Z, okay? For any N, for all N, this happens, okay? So keep this in mind. It will be helpful for you. Okay, so now come to the part B. I will solve here some selected questions. Okay, so but how many of okay?
So
Yeah.
in the 18th question,
18th
we
question.
got D by Bézout's lemma.
What?
We used Bézout's, no, here.
Yeah.
So, but we also know GCD is 1.
Yeah, GCD is 1,
So then would that make I intersection ZZ, because we can multiply by any integer on the RHS?
no, but you can multiply by any integer, but that multiplying by any integer will not say, I mean, you will not get, right? Suppose you multiply by 2. That doesn't mean that 2 of QX is inside ZX.
Okay, okay.
Uh,
Yes.
Right. So come here now. Okay. So let me ask you that most of you say, I mean, most of you have written that this is an irreducible polynomial, but is it easy to see that this is irreducible? You did it in the exam. Why it is irreducible?
Yes, sir.
Why?
By irreducibility mod P test.
Which mod P?
Sir, if we take Z3, it is
3.
irreducible over Z3x.
How?
So
How?
because if we take 0, then put P0, then it is comes 1.
Right, but you want to say that it does not have any root in Z3.
Yeah.
But that doesn't mean that it would be a reducible, I mean, irreducible polynomial there.
Sir, at first, when we put P0, then it comes 1 square, 2 square, 3
Okay,
square.
fine. I understand that.
Then it
Right.
is multiple of 3.
I understand that. What I mean to say that, yeah, even if it does not have a root in Z3, it might reduce there because this is a polynomial greater than degree 3. The test you are applying, I mean, that does not make sure that it is irreducible over Z3. Okay, you are just only checking roots, right? But if it does not have any root in Z3, that doesn't mean that it is a irreducible polynomial over Z3. It may reduce because its degree is greater than 3. Okay.
Sir,
Yes, sir.
Bolo?
Sir, let us assume that it is reducible over Q, and x minus p is a factor of px.
Why x minus p is a factor? No, why it is a factor? I don't think that it is a factor.
Sir,
What is
we are proving by contradiction that it is irreducible over Q.
No, okay. So, but why? What is the p? X
Sir,
minus
p
p
is any rational number.
Irrational number.
Yes, sir, any rational number, and we will prove that if we divide it by any rational number, we will get a factor. Remainder which is not 0. Hence, it is irreducible over Q. So, if x minus p divides px, this implies that p of p should be 0.
But what? How x minus p x how x minus p divides it?
We are assuming that let us assume that x minus q, where q
okay. Let me tell you
where
that
q is an irrational number.
Okay, but I'm not getting that. What do you
सर
mean to
मेरा
say?
कहने का मतलब ये है कि
हाँ,
अगर ये
बताओ।
रिड्यूसिबल है
हाँ,
तो x माइनस q शुड बी अ फैक्टर, मतलब कोई फैक्टर होगा इसका।
नहीं, ऐसा नहीं होता है।
सर रिड्यूसिबल मतलब वी कैन रिड्यूस इट इनटू मेनी फैक्टर्स।
नो बट ओके, ठीक है, मैं बता देता हूँ तुमको जो तुम कह रहे हो, ऐसा नहीं होता है। अगर कोई पॉलिनोमियल रिड्यूसिबल होती है तो उसका कोई ऐसा फैक्टर को जरूरी नहीं होता है। ओके, उसके दो क्वाड्रेटिक फैक्टर भी हो सकते हैं, जैसे ये है, आप देखें तो ये पॉलिनोमियल है। ओके, इसका कोई भी फैक्टर नहीं मिलेगा आपको इस तरीके का। ये reducible है because it has all complex roots, so that need not be true. Okay, so let me tell you that. Okay, how do you do, students? So just write it px equal to fx into gx. Okay, It is indeed irreducible, but I mean, you may apply, some Einstein criteria. You might, you will try first to apply some tests, but that would not work really. You just see that in general you prove it. Okay, this is very, very good problem. You can try at home. But still, most of you thought that okay, irreducible ही होगा, चलो तो लगाओ. Irreducible कहाँ हो रहा है 2-3 नंबर लेके ना, क्योंकि irreducible तो किया ही है आप लोगों ने. बट ऐसा एग्जाम में मत करना. ओके, डोंट डू दैट थिंग इन एग्जाम. इट वुड कॉस्ट यू अदरवाइज. Not every time for the polynomial
Sir,
is
can
irreducible. Huh?
can you repeat, sir?
Can we?
Can seventh question, sir?
Sorry, I can't hear you. I think I'm not. I mean, there is some problem in the connection from your side. Maybe I'm not getting the voice clearly. Okay.
Sir.
Yeah. Okay. So
Sir,
now.
I've done it in this.
Okay, let me tell you, because we have less time now. Sorry for the, I mean, not giving you all time because we have less time. Let me tell you, okay, I mean, quickly tell you that how do you solve some question. Okay, let me give you hints. Okay, because I would not be able to cover all the questions, right? Let me give you a hint. Okay, so just prove it for in general. Okay, this type of polynomial, these are integers, is always irreducible. Okay, so how do you do that? Let me tell you. So just see that it is, assume that it is reducible. Then you can factor it in two non-trivial polynomials, right? Non-trivial factors, right? Non-trivial factors means you understand, right? None of them is unit. So see, now what is the value of G? I mean, use this thing, okay? GA1, GA2, dot, 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 GAN is going to be 1, right? So at n values, it takes a value 1. Now see that what can be the degree of G and F and G, okay? Use the degree arguments. And so you know that suppose the a polynomial G has a degree, n, say, then and some other polynomial has degree, say some other polynomial f has degree n. If they are agreeing at n plus 1 points, then they must be equal, right? Using something like that. Okay. I mean, that would help you to decide that this polynomial, to prove that this polynomial is irreducible. Okay. I don't think that some test will work here. The irreducibility test. Okay. So, but yeah, this will help you. Just see that what can be the degree. Okay. So, okay, let me ask it here. Suppose that n equal to 2025. Okay. Then what can be the degree of G? What cannot be the degree of G? Let me know about it. What cannot be the degree of G? Anyone? Because G has value 1 at n points. Okay, use it and do it. Okay. So because I have to tell you the solution of other questions. Okay. So how do you solve this? For this, just see that this subgroup has a finitely generated subgroup, right? The same argument, and this one does, as some of you said, that this does not have a finitely generated non-cyclic group. This is a finitely generated non-cyclic, but here every finitely generated subgroup is cyclic. Okay, that's why this is not possible. Okay, so and you know that how to solve this, right? There is exactly one commutative ring with unity of order 55, you know, right? Because we have did this in the last class. Okay, so there is always a surjective ring homomorphism from ZX to FQ for all Q, and where Q is a, what is Q here? Can anyone of you let me know? Where Q?
A prime power.
Yeah, a prime power. So some of you think that it is a prime only. How many of you think that this is just prime? 2, 3, 5. You did not read the notations and conventions, I think. Yeah, it is written here. The Q is a prime power. In that case, by mistake, you can correct it. Okay. I mean, that is easy to write. It is easy to see that ZX, this FP is a quotient of ZX. So how do you prove this? Let me tell you. Okay, I'm not going to ask you, just letting you know that suppose that this is FP to the power R, right? You can write it FP alpha, right? This alpha is the say this is your field, then this is a cyclic group, right? So it will generated by alpha. So and it is an extension of okay, let me not say extension because most of you have not read about it. So this contains FP, right? Filled with P elements, because you know any commutative ring with unity with characteristic P contains FP or ZP. So this is just FP alpha, the smallest field which contains FP and alpha because of this. So what do you do? The ring homomorphism of ZX determined completely by, can you any one of you complete it? Completely determined by the ring homomorphism. Completely determined by
X goes to alpha.
yeah, the image of X, right? So X goes to alpha. So define. So this will give you a unique homomorphism. Then the unique homomorphism from ZX to FP alpha, which is obviously onto, okay? Because anything on the right hand side is just a polynomial in alpha with coefficient from FP. Okay. So this is obviously a surjective homomorphism. Okay, so let me come to, okay, so let me see that if this I have already told you, right? This one, this I have already told you in the class. Okay, and this also I have told you in the class, right? There was a discussion. Okay, so about this, so take what you have to take some metric, finite metric space, which has some point, okay? Pick some point. You can find about, it is an exercise for you, okay? And from this finite point, you have say infinitely many points, okay, like this. Let me denote it by a circle, but that doesn't really mean a circle, okay? Suppose you have a you have find a metric space which have a point alpha and it has infinitely many points, say alpha 1, alpha 2, all the distance between all these points. Okay, so let me write it here. Alpha, alpha 1, alpha 2, dot, dot, dot. Okay, so say alpha 20, 20. Okay, say alpha 10 to the power 5. Okay, so try to define a metric in this space where there is a, you know, say alpha is fixed and from alpha the distance of every point is 1. Okay, I mean you have more than 20, 25 points and the distance between any these alpha is also 1, like they are like this. The distance between alpha 1 and alpha 2 is 1. The distance between alpha 2 and alpha 3 is 1. The distance between alpha 4 and alpha 5 is also 1. So this cannot happen here, okay? This is just a rough, I mean, I'm telling you roughly, okay? If you don't know this, just see the solution of the exam 2021 in the YouTube, okay? I have done that. So the same idea is used there. Okay, so this is, I mean, true, okay? You just have to do some, you know, work. You can, I mean, this is always possible for any odd, maybe even also, okay? Even it's easy, right? You can do that, I know. But for odd, it's not really easy, but this is possible, okay? Try to make an example. And if you cannot take an example, just ask me in the Telegram. I would give you the example, but this would be very good exercise for you. Okay, so this one, this one, this one. Yeah. So let me tell you, if the group is uncountable, then it's fine. If it is not uncountable, it is countably finite, then what do you show? That this is isomorphic to this one. Okay. And this has uncountably many subgroups. How do you show that? So just pick its generating set. What is that? E1, E2, dot, 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 right? And take any subset of natural number corresponding to that. Say if you take 1, 2, 3, then take the subgroup generated by E1, E2, E3. Okay. And if you take 3 to 4, I mean the subset 3, 4, 5, then consider this one. Okay. So let me write it here like that. Then for any subset of natural number, you have a subgroup, right? What is that? Say as many elements are in X and name them X1, X2, dot, dot, dot. Then take the subgroup generated by EX1, EX2, dot, dot, dot. Okay. So, but so that they are different. Okay. For each X, you get a unique and the only, and that cannot be God for any, that cannot correspond to any other subset. Okay. So, and this one I have told you, this one I have told you, this one I have told you, this one. For this, you take this, okay?
So in the earlier one, with the number of infinite, in Z plus, we have an infinite group and we do not have any element of order 2. So then we get the immediate counter example. No?
What does this say? The number of subgroups of any infinite group, read the property whose every non-identity element has order 2. So what the counter example you have?
Z plus.
Z plus means?
Z comma plus additive
group
okay. Under integers.
Okay, but does it satisfy this thing? Every non-identity element has order 2. No, right?
There is no such subgroup, so it is countable.
Yeah, it is countable. So
counter example.
No. I think you misinterpret it. The number of subgroups of. Okay, now read it.
Oh, the infinite group has non-identity element. Every non-identity element.
No. So replace it G. Okay, and G is a group whose every non-identity element has order 2. So Z plus is not a candidate for G. Okay.
Got it, sir.
So yeah, this one I have also told you, right, in the class. Okay, for this you take this one, okay, and say that let me show you how do you show this, so that this chain does not terminate. Okay, but in a UFD, you know, in a UFD what happens? The ascending chain of principal ideals, okay, keep that in mind. Not all ideals, any chain of arbitrary ideals, not. Principal ideal always terminates. Okay, in a UFD, but this will not terminate. This will not terminate. This will not stops. This does not stop. Okay, I mean to say. You can check that. So this is wrong. Every subgroup I have told you, right? This requires some work. Okay, I will write the construction. Okay, this is possible. I mean, I will write the construction. Okay, so you just, try to take n and fix a prime. So write n like this, n dash p to the power v. Okay, take the maximum power of fix some prime, and for each natural number, write the natural number like this, n dash p to the power v. Okay, then the GCD of p to the power n dash is 1. So write like this. And there exist xn and yn, right? So xn, yn, n dash is equal to 1, right? By the definition, because every natural number can be written like this, right? If you have fixed a prime, then extract the maximum power and n dash will be remained. This might be 1 also. Then GCD of this p to the power v and n dash will be 1. So there exists xn and y1. So now do it. Okay. So now think that what you take, I mean, what should be taken in place of an? Okay. This is exercise for you. I mean, I have told you so much, and this is very easy. I know that you have done it. So how did you solve this question, by the way? Some of you did it. How did you solve this?
The idea
Yes,
lies
sir, I've
in
done it.
matrices.
Huh?
Sir, I've done it like if eigenvalues of A is lambda1, lambda2 and eigenvalues of B is mu1, mu2, then lambda1 plus lambda2 equal to mu1 plus mu2. First equation, and second equation is lambda1 square plus lambda2 square.
No, I'm not asking this one. I'm asking this one. Why this does not exist? A lot of you take that this does not exist. Let me know why this does not exist.
Actually, the idea is from van der Monde matrices.
Huh?
Actually, the idea behind how I solved it, the main idea is the van der Monde matrices have non-zero determinant when.
Okay, so you make some. Does that work?
Actually, I assume that suppose the eigenvalues of capital A in C.
Lambda1, lambda2, dot, dot, dot.
Lambda1
right.
has multiplicity M1. Lambda2 has multiplicity M2.
Okay, but there
Algebraic multiplicity. And so on. Then we can set up equations.
Okay, so right. Okay, in this way, that
then
is
a van der Monde matrix will come. So as
okay.
a result, all these mi's will be 0.
Okay, but let me tell you it's a solution. Where is it's a solution? Okay, so this is a problem told to me by some of my friend, okay, who is also my colleague. So he wrote its answer in Maths Exchange also. Okay, you can search about it, you will get. I mean, the answer is written by one of my friend. Okay, so the answer involves showing the something is nilpotent, like, okay, showing this nilpotent and using a very good argument. Okay, so please watch that, look at that. Okay, I'm not writing the solution here, I'm just giving you the reference. You can do that, but in that way this can also be done. Okay, so what Sagnik says, I think Sagnik said, right? So how did you solve this? Have I told you about this in the previous lectures? Yes, I think, right? I don't remember because I might have told it somewhere else also. Okay, right? So have I told you about something like this, that if A is invertible and diagonalizable, A square is diagonalizable? No, right? I have not told you about it, right? Okay, let me tell you. Okay, so A 2025 has a minimal polynomial, say mx, right? Then it will satisfy something like this. The minimal polynomial will have distinct roots, right? Lambda r, say. But if you put here A 2025, that means this happens, right? A 2025 lambda r equal to 0. But then just you see that A satisfies here or some polynomial which does not have distinct roots, right? So solve it further. Then how can you make a polynomial in A from here? Something, this will be lambda, here lambda1 will be some 25th root of lambda1, like that. Okay, dot, dot, dot. All these roots will be distinct. Okay, just to do it for A square first. Okay, you will understand what do I mean to say. Okay, solve it. And this one, this is I mean easy to show that this space is nothing but equal to this. Okay, A belongs to M 2025 R, trace A equal to 0. You can show that because obviously every commutator belongs here. But all you need to show that if some matrix has trace 0, then that can be written in linear combination of commutators. Okay, So this I have corrected this one. This was actually wrong, and this is easy to solve. Okay, see that. So this one, you have a homomorphism, right? For each G, because G has finite order, then you get this. By the property of homomorphism, you see this. So your every matrix in the image going to satisfy this polynomial. And you know such a matrix is always diagonalizable. You know that. I know that you have solved too many questions, right? Yeah. Okay, this is again something, not difficult. It's not difficult. Okay, just take the example of Z2 cross Z2 and Z3 cross Z3, Z2 cross Z2, and try to generalize. Okay, so I would stop here. So sorry for the telling you so quickly, because I know that some of you did not understand the arguments, but I have no other option to, because otherwise I would not be able to cover it. But what I said that at last I will give you something. Okay, so before, yeah, you have one day. Okay, so I suggest to you that please solve at least 20-24 question for exam fully. Okay, so I will send this mock test to you also. Okay, these notes also. Sir will forward this to the group, but I will send a hand. What I said, that unsolved book in which TFR problems are listed, and that is a very good document. You can use that. Okay, so I will send it. Okay, you will get that. But yeah.
Okay, Lalit, please do share that PDFs with me. We can forward to them.
Yeah, I will share it.
And one more thing, we can make some announcements about tomorrow's program, about the time change.
Yeah.
So what is your plan, Lalit? Either to start at 6 p.m. or 6:30?
Yeah, we would start at 6:30, and I would be winding up it by 6:30, 7:30. Tomorrow mainly I will be talking that how someone's be in the exam, right? So we should not make mistakes like that. I would be letting them know.
Yeah, that will be more useful in the very last moment of an exam.
Yeah.
Certainly, as you have qualified and come out with great success in all these exams, certainly you will have something to share with the people. So I'm sure that it will be really beneficial.
Yeah.
So dear friends, tomorrow our session will be at 6:30 p.m. 6:30 to 7:30, and at 8:30 we have the regular practice test series that you can attend. Okay, the links are being shared in our groups. So all the very best for your exams. Let your preparations go on well. So once again, I would like to thank Mr. Lalit for taking all the efforts to have these sessions and mock test and discussions and all that. So thank you, everyone. Lalit, shall we wind up here?
Yeah, sure. Let me stop the recording.
Okay. Okay. Thank you, everyone.